Solving trigonometric equations that have multiple angles involved is a little more challenging. It's just an extra step we need to worry about near the end. We'll start off by solving it for cosine of whatever, just like we did before. And so in this case, I'm looking at, let's see, I'll divide both sides by -2. That gives me cosine of 4 theta equals the square root of 3 over -2, or we could say it's negative square root of 3 over 2. At this point, we need to figure out what angles cosine will give us negative square root of 3 over 2. And to start off with our unit circle, cosine is our x value, so we're looking at x values here and here, and the x values with negative square root of 3 over 2 are an angle measurement of 5 pi over 6 and an angle measure of 7 pi over 6. However, we need to look at this a little bit more. This 4 theta, if we want theta to be between 0 and 2 pi, we need to figure out what 4 theta is going to be. And we can multiply each of these three terms by 4, and that tells us that 4 times 0 is 0. 0 is less than or equal to 4 theta is less than 8 pi. So in order to get all of the thetas that they're looking for, we need to go around this circle 4 times. So our 4 theta, the thing that we take cosine of to get negative square root of 3 over 2, that 4 theta is going to equal 5 pi over 6. That 4 theta could also equal 7 pi over 6. And then we need to go around the circle again. Now remember, a circle is 2 pi radians, and 2 pi would be the same as 12 pi over 6. So I can get to the next coterminal angle with 5 pi over 6 by adding 12 pi over 6 to it. So that gives me 4 theta equals 17 pi over 6. And adding 12 to 7 pi over 6, I get 4 theta equals 19 pi over 6. And continuing on, we get 4 theta equals, let's see, 12 more would be 29 pi over 6. 4 theta equals 31 pi over 6. And we need to go a 4th cycle around the circle. 4 theta equals 41 pi over 6. And 4 theta equals 43 pi over 6. Again, we needed to do this because we're looking at 4 theta as our input, not just regular theta. And so we need to look at how many circles would include 4 theta if our answers all need to be between 0 and 2 pi. So we multiply each of our segments of this inequality by 4 to get that we need to include every angle between 0 and 8 pi. Alright, let's see, and just to be sure, 8 pi would be 48 pi over 6, so we haven't gone too far, but if we added 12 more we would go too far. Now we have 8 equations we need to solve. Now fortunately they're not that hard to solve because all we need to do is divide both sides by 4, and that gives us theta equals 5 pi over 24, theta equals 7 pi over 24, and so on. Now I noticed on the homework some of these problems are ones that are set up to where there's a checkbox where you check off which of the following group of maybe 6 or 8 answers is a solution. Not all of these solutions will be listed necessarily. They might be listed, or if in a case like this where there's 8 different answers between 0 and 2 pi, they may not all be listed. For example, looking at this last one, theta equals 43 pi over 24. This is less than 2 pi. And again, if we had just gone around the first circle, we would have only ended up with these two answers. We would have missed these other 6 answers. So we need to be careful. And that's the main complication with these multiple angle exercises. Let's look at tangent of theta over 2 equals 1. Now this is a multiple angle, but it's a half angle instead of a multiple of 2, 3, 4, whatever. So first thing I'm going to do is look at what my theta over 2 is going to be between. If I take this inequality, compound inequality, from negative pi to theta, or theta is between negative pi and pi, divide everything by 2, I get that negative pi over 2 is less than or equal to theta over 2 is less than pi over 2. So when I'm trying to solve this equation, when I'm looking for values that satisfy tangent of something equals 1, the somethings I'm going to look for are going to be between negative pi over 2 and pi over 2. And that actually makes it a little easier for us in this case. So if tangent of theta over 2 equals 1, we remember that the angle that gives us a tangent of 1 is going to be at pi over 4 and at 5 pi over 4. That's where my tangent is positive, and that's where its value is 1. Since we're only looking from negative pi over 2 to positive pi over 2, let's see, if we go negative, this 5 pi over 4 is co-terminal with negative 3 pi over 4, and that's too far in the negative direction. We're only looking for values between pi over 2 and negative pi over 2. So there's only one value for which we have an answer. So we get theta over 2, the thing we're taking tangent of, has to equal pi over 4. Then we can complete this problem by solving it the rest of the way, and the way we'll do that is by multiplying both sides by 2, and we get theta equals 2 pi over 4, which is pi over 2. And so in this case, the theta over 2 ended up giving us fewer answers than we might expect, instead of more answers. Another problem, and I noticed after I had typed this one in that I had 4 theta on 2 different problems and didn't want that, so I changed this one to 3 theta. Sine of 3 theta equals 1/2. Again, we need to figure out what angles we're looking at. And so if we change this to be in terms, change the inequality to be in terms of 3 theta, we get 0 is less than or equal to 3 theta is less than 6 pi. So in other words, when we're looking for sine of something equal 1/2, we're going to need to look at the first 3 cycles, 3 circles around. So sine of what equals 1/2? Well, let's see. On our unit circle, sine is our y value. So that would be 1/2 at these 2 points. So that would be at pi over 6 and at 5 pi over 6. So once again, we've got 3 theta, which is the thing we're taking sine of. 3 theta is either going to have to be pi over 6 or it's going to have to be 5 pi over 6. And in order to make sure that we get all of these, we need to go around 2 more times, 2 more circles. And again, since we're talking about pi over 6's, we can recall that 2 pi, or a full circle, is equal to 12 pi over 6. So I can add 12 pi over 6 to both of these, and that gives me my next set of answers. 3 theta equals 12 pi over 13 pi over 6, and 3 theta equals 17 pi over 6. That's 2 circles. I need one more, so 3 theta will equal, add 12 pi over 6 to 13 pi over 6 gives me 25 pi over 6, and 3 theta equals adding another 12 pi over 6 to 17 pi over 6 gives me 29 pi over 6. And at this point I need to divide each of these equations all the way down by 3 to get theta by itself, because what I want to solve for is theta. I want a theta that is between 0 and 2 pi. Dividing each of these by 3, I get theta equals pi over 18. I get theta equals 5 pi over 18. I get theta equals 13 pi over 18. I get theta equals 17 pi over 18. I get theta equals 25 pi over 18, and I get theta equals 29 pi over 18. And again, you notice that once we've divided by 3, all of these angles are once again between 0 and 2 pi.